Hello class, today we'll be talking about 12.4, the normal distribution. So in this section, we are going to recognize characteristics of normal distributions. We're going to understand the 68, 95, 99.7 rule. We're going to find the scores at a specific number of standard deviations from the mean. We'll use the 68, 95, 99.7 rule, and we'll convert a data into a z-score. So let's look at what normal distributions are. So normal distributions are also called bell curves or Gaussian distributions. Normal distributions is bell-shaped and symmetric about a vertical line through its center. So the mean, median, and mode are all equal and are located in the center of the distribution. So basically it's saying that we have, if you look at this last one right here, we look at this one. We have the bell-shaped curve. Now all these have a bell-shaped curve. If we were to actually go through these, it has a bell-shaped curve. All these have some type of bell-shaped curve, where in the middle is where the mean, the median, and the mode are all the same. So let's look. Now, we have different type of bell-shaped curves. It says the shape of the normal distribution depends on the mean and standard deviations. These three graphs have the same mean but different standard deviations. As the standard deviations increases, the distribution becomes more spread out, but retains the bell-shaped curve. Now, if you look at the blue, and I'll just trace it with blue, the blue one is your normal distribution. Then, let's say if we're a little bit closer, and let me use the green. This is the standard distribution of this one. Now, as the standard deviation spread out, we have this purple look, which goes like this. Let me see if I can trace that a little bit better. That's a little bit better. All right. As you see, it's more spread out. Now, honestly, right now, you're not going to worry about all that. It's just showing you different standard distributions. So let's look at what we're actually going to be looking at. So looking at standard deviations and looking at the 68, 95, 99.7 rule, approximately 68% of the data falls within one standard deviation of the mean. That means in both directions. So it's basically saying from this point to this point. So this is 68%. So that's your 68%. Now, if we look, it says 95% falls within two standard deviations. So it's talking about from this point to this point, including everything that's in here. And last but not least, we have what? 99.7 percentile, which is three standard deviations, and it's talking about all of this. Now, you have to keep in mind that, remember, if to get 100% of the whole graph, you still have wings. So it's about what? 0.3 left. So over here, you'll still have 0.15. And you'll have what? Over here, you'll have 0.15. And that makes up your whole 100%. So do not never leave off these right here when you're talking about different standard deviations, because what happens if you are going to all the way from the left, you have to go make sure you include that 0.15. Now, finding scores at a specific standard deviation from the mean. Male adults' height in North America are approximately normally distributed with a mean of 70 inches and a standard deviation of 4 inches. Find the height that is 2 standard deviations above the mean. So basically, we will have height is equal to mean plus 2, because we, 2 standard deviations above the mean, times the standard deviation. So we have this. So this will just equal the mean, which is 70, plus 2 times what our standard deviation, which is 4. So 2 standard deviations from the mean would be 70 plus 8. So this would just equal 78. So 2 standard deviations from the mean would just be 78. Or you can look at it as you're just adding 4 for each standard deviation. So if we were to look at a bell-shaped curve, and let's say that this is our middle, our mean is 70, so we have 1 standard deviation, which would be 74. Then we have 2 standard deviations, which would be 78. Then when you go the other direction, you would subtract 4, right? So if we went to the left, we would subtract 4, so that'd be 66, then 62. Now, you could go to 3 standard deviations both right ways, but we're just talking about the 2 standard deviations. Now, this is going above this direction. So this is above the mean. This direction is below the mean. So you have above the mean and below the mean. All right? So keep that in mind when this question asks you that. So let's look. It says use the distribution of male adults' height in the figure to find the percentage of men in North America with heights between 66 and 74 inches. So now we're talking about from 66 to 74. All right, so we're just talking about all of this in here. Now, as we discovered before, what did we get? It's the 68th percentile, right? Because we know from here, from 1, or 1 negative 1 to 1, will be from 1 standard deviation from both sides, which will give us 68%. So that's the 68th percentile. Now, when we're computing z-scores, a z-score describes how many standard deviations a data item in a normal distribution lies above or below the mean. The z-score can be obtained by using z-score is equal to data item minus mean all over the standard deviation. The data item above the mean has a positive z-score. The data item below the mean have a negative z-score. The z-score for the mean is just 0, because that means it has not moved anywhere. So just keep that in mind when you're doing these problems. because you want to make sure you calculate this correctly. All right, let's look at this problem. So looking at this problem, it says computing z-scores. It says the mean of a newborn infant is 7 pounds, and the standard deviation is 0.8 pounds. The weight of a newborn infant is normally distributed. It says find the z-score for a weight of 9 pounds. So when we look at this, we have to use what we got. So remember, it's z-score is equal to data item. So z, and let me change the color. So z is equal to, now, and I'm going to write it in terms that we used before, so it'll be x minus x bar all over standard deviation. Because that's what? Z-score is equal to data item minus the mean over standard deviation. Now, we know what our what? Standard deviation is, and we know what our mean is. So, let's do this. So, we're going to have z is equal to 9 minus 7 all over 0.8. So z is equal to, now we put this in a calculator, we'll get what? 2.5. Because you'll get 2 over 0.8, which this is just what? 2 over 0.8. And then it gives us a z-score of 2.5. Now, make sure if you got any questions, you make sure you send me a message through Microsoft Teams or you send me an email. So let's keep going. So it says intelligent quotients or IQs on a Stanford-Binet intelligence test. It says are normally distributed with a mean of 100 and a standard deviation of 16. What is the IQ corresponding to the z-score of negative 1.5? Now, the negative sign in negative 1.5 tells us that the IQ is what? 1.5 standard deviations below the mean, or 1.5 standard deviations below the mean. Because the negative is saying we're going to the what? Left. All right? So let's look at this. Now the score is equal to what? The mean minus 1.5 times the standard deviation. So we're going to say we got it equal to, the mean is what? 100 minus 1.5 times, then we have a standard deviation of 16. So therefore, if we were to keep going, it'll be 100, and it'll be minus what? 24. And that'll be equal to your 76. So our IQ corresponding to the z-score of negative 1.5 would be what? 76. All right, percentiles and quartiles. It says if n percent of the items in a distribution are less than a particular data item, we say that the data item is in the nth percentile of the distribution. Quartiles. Divide the set into 4 equal parts. The 25th percentile is the first quartile. The 25% of the data falls between the first quartile. And it says what? The 50th percentile is the second quartile. The 75th fifth percentile is the third quartile. So it just broke it up into 4 even parts to put it in quartiles and percentiles. So percentiles, interpretation for z-scores. Using the z-score in a table that you can find the percentage of the data item that are less than any data item in a normal distribution. In a normal distribution, the mean, median, and mode all have corresponding z-scores of 0 and are the 50th percentile. Thus, the 50th percentile of the data items are what? Greater than or equal to the mean, median, and mode. Now, you can find this table that they're talking about is going to be in your book. All right? If you look in this section, you should see a big table in your book. So let's look. So, for poles and margin of error, it says statisticians use properties of normal distribution to estimate the probability that a result obtained from a single sample reflects what is truly happening. If n is the sample size, there is 95% probability that it lies within 1 over the square root of n of the true population statistic. So plus or minus 1 over the square root of n times 100% is called the margin of error. So basically we're going to find the margin of error. So I would write this down because we're going to use it. So let's look at an example. It says using and interpreting the margin of error. It says in a random sample, 1,172 children, ages 6 through 14. All right, 17% of children say getting bossed around is a bad thing about being a kid. So let's look at what we got. We know our sample size. We got n is equal to 1,172. All right. So we basically got plus or minus 1 over the square root of 1,172. And this is equal, and then we have to do what? Multiply this by 100%. So we multiply by 100%. And then this equals roughly around about plus or minus 2.9%. So give or take 2.9%. Now, the next thing they ask you is to draw a conclusion from this. So you got to draw a conclusion from it. It says write a statement about the percentage of kids who feel like getting bossed around is a what? Bad thing about being a kid. Now, we're going to say we remember 17% said this, right? So we're going to do 17% minus 2.9%, which will give us about 14.1%. Then we're going to have 17% plus 2.9% is going to give us what? 19.9%. So if we were to think about it, that it lies in between 14.1% and 19.9%. So let's keep that, just keep that in mind. Because this is the what? We found the margin of error, and this is the basically margin of error that we have. It's between 14.1% and 19.9%. All right. This is the end of 12.4. So make sure if you have any questions about this, you send me an email, you send me a message through Microsoft Teams. That'd be the quickest route, and then I can help you right on the spot. All right? Have a good day.